Welcome everybody to a new tutorial series by Nyjo. I'm Alessandro Candelosi, founder and instructor at Nyjo, and today a lot of guys will be really happy because in the past we created this preview about an orange juice test setup, and everything was done with the LiquiGen, the 03 alpha version, and a lot of you asked for a tutorial, and we are ready to release this tutorial series. So you see, that's what we done in the past, and today we are going to prepare something. It will be just a little bit better than the previous one. We'll have a different battle because we have to use free model and free assets, but we are going to create something really great using LiquiGen. So today we are going to use LiquiGen as we said, and in the first part we are going to create just a setup for the fluid using different emitters and forces to create this simulation. So let's start learning how to use LiquiGen in production to achieve effects like this one, controlling the fluid, generating the mesh, and then exporting everything to another software to render everything in a really nice quality. So one idea is to pick something free. You can go in any 3D website where there are library of 3D models. By the way, for example, I found this one over Turbo Squid, and this one is completely free, so you can download it. And it is not bad. It's a simple model, but we can use it to simulate something. So the idea is to use this one. You can download in various file format. There is also the OBJ and stuff like that. By the way, I picked the 3ds Max scene, so we have everything. And for example, that's the glass, so we can try to export this one. I try to have a deeper amount of polygons, and then I go to export this one in 3ds Max. You can directly pick the OBJ or pick the OBJ, use Blender, Houdini, or whatever else, also Maya. It's not a problem. So export selected, and I'm going to create a folder for this project. Let's call it orange. Okay, so now we go to create a folder, assets, and here we put the model, and let's say that this one is the bubble. Let's go with OBJ. Let's leave all the default, it's not a problem, so everyone is going to work on this model as they prefer. So now we go to open LiquiGen, and we start preparing the basic setup. Let's say no, discard, we don't want to load the crashed scene. Okay, so that's the basic simulation we have inside LiquiGen as soon as the scene is open. Now we get to import something, so we need the import node, and this one can be renamed to import, or maybe just in, so we know that this one is the input, and let's call it bottle. Okay, so we have the model. Let's try to use this one as a collider, so we have the possibility to see which is the dimension. So actually it's say that the model is here, so we have just to say which is the model we like to open. Let's go inside orange, assets, bubble. Okay, let's go to rotate, and we go to rotate this one. Okay, let's say 90 degree. And for the moment we stay with this setup for the position, but we can also directly move it there. Let's go to have a smaller emitter, and then we say to have no visualization, so R, and then we press. Okay, you see that it's starting to simulate in the right way. By the way, it is not filling the bottle, and that's really simple. It is not filling because inside the emitter we have the lifespan, so we don't need the lifespan. if we go now to simulate, obviously it is going to fill the bottle step by step. Okay, so that's really simple. Let's go back here and say that the resolution is, we can use the absolute, so you go to say which is the focal size, or you can use the percentage. So if you like to have a better resolution for the volume collision, you get just to have a higher level. So we try for 200, and the shape should be better than the previous one. Okay, so let's start preparing a better setup, because now we have what we need. So we know that this one is the bottle. Let's say that the albedo is black, it is reflective, and about the reflection, the refraction is lower, so we go for something like that. And let's say that the ground is a uniform color, so we go for something like that for the moment. And about the lighting, we go to pick an HDR map. You can download something freely from Polygon, from HDR Heaven. I'm going to use essentially, let's try with this one maybe. Yeah, let's try with this one, because we don't need something so complex, so maybe this one is okay. So let's go lower to something like that. Okay, so now we have the glass, and we have also the filling. But obviously if you try to use the path tracer, it is more precise, so you can see more stuff, everything together. So let's imagine that here we can remove completely the roughness, and we can have also a really low amount of absorption. And then if we go here, we can add a material, so let's say an appearance, and this one is the liquid material. Okay, and here we can control the material. You see that we have a ramp, we have a gradient, we have a single color. So let's say that we like to have something that is similar to Northern Jewish. Obviously I'm going to create something really basic, so I'm not taking care about how it should work on how it should look. Okay, let's go maybe to something like that, and then we go or something that is similar to a yellow color. And then you see that if you have an higher absorption, it will pick the color. Obviously we are not going to render here. By the way, you know, it's interesting to see how it looks. So let's say that, for example, we have also an emission, and you see that we have a nice coloring. We can go to simulate something to make it more visible just using the emission. It's not the right way, but it's good to see something in the view, and then you see that it's going to play inside the scene. By the way, let's go back to having no path tracer, and we go to play just with this fluid, and you see that it's working perfectly. Let's remove this collision, and then about the emitter, we go inside the emission, and we say that we like to have an higher emission. Okay, so you see that we have a higher volume of liquid. Let's go back here, and let's say maybe 10. So it is more and more. Okay, then let's go, this one is the gravity, so let's call gravity, and then we can play over the simulation. If you get to have a little bit higher 0.8 voxel size. Obviously now it is smaller, so we have more details, but we start also to have some kind of, you know, problem and issue. By the way, I don't want to have something like that, so we are going to have something really near to the ground. We could also go maybe more near to the ground, okay, something like that. We have some really nice turbulence. And about the other parameters, let's try to say that we have a direction, and we say that we have direction to y, and let's see if the speed is too much. Let's try, it should be enough. Okay, so you see we have a nice turbulence. Okay, let's try to replicate the emitter. So we go to have another one in a similar way, but this one is on the other side, and the emission is, let's see, it's going to -1. Okay, so you see that we have two turbulence moving inside the fluid. Okay, let's get to save the actual setup. It's really basic, but we are starting to play with something that's starting to work. Let's create a new folder, scenes, and inside scenes we call this one orange fluid setup E001, and let's say that this one is fluid bottle interior setup. Okay. Okay, it works. So if we like to generate some small differences, we can say, for example, that this one is smaller. Maybe we have an area speed, and maybe this one is going to add more liquids, so we can say, for example, 15 R, and then we press, and in this way we are going to create something that is, you know, a little bit different, because we have some variation inside the fluid, and that's what we are achieving. That's really not bad. So let's say that we go to create a comment here, and this one is internal emitters. Okay. Then let's go, this one is a force, we can have it there. This one is the collision inside the bottle, and then we have the liquid appearance. We're still working on something that is still really simple. Let's see what's going on if we go to have a lower level of flip fluid, because, you know, this fluid is not so big, so maybe we can try to have something with less splash inside. But, you know, we are losing a little bit of details, so let's go back to 95 for the moment. Okay, let's try to have a really small amount of stiffness, just a little bit, you know. And let's see if we go lower with the resolution using a smaller voxel size. Okay, you see that we are adding a lot of detail inside the fluid. It's going slower, obviously. Maybe we need a little bit more iteration, because, you know, it is still near. Let's try with 150, because it's going to use all iterations we have, and also about the particles. We need for sure more particles, because you saw it's not able to do its job. It's good the amount of voxel we have, but here we have to take care about more particles. Let's try to 25 million particles, and now we should have enough particles to play with. Remember that we have 13 gigabytes of memory used. So we have to imagine that when the fluid is up, maybe we have to do something to maybe to lower the memory usage, you know. By the way, to make the test, we can go higher. Let's go back to 008. We get to use 2 substeps to be more precise. So we have this one that is going to start, but we have to change maybe just a little bit the position. So let's go a little bit lower there and a little bit lower there. So you see that it's more near the ground. Okay, and maybe this one is, you see, more near to the side of the bottle, and the same for the other. So it's faster, but okay, we are a little bit outside the bottle. Okay, now we are inside. Okay, nice. You see we have some nice turbulence. And then the idea is that if we have an additional emitter, let's say that we go to clone this one, and we go to connect, and let's say that this one is maybe a little bit bigger. Let's try to see. Obviously it needs to be inside, but that's too big. Let's try with one. Okay, you see that this one is really big and can give a lot of boost. So let's remove the speed, and we say that this one will start to emit water later. Let's say maybe after 250 frames. So the emitter activity is animated, and then we can say that now it's set to off, and let's say that there is set to on. Okay, in this way you see that we have the initial emission, and then we have the other one. By the way, it's still soon, so let's go there and let's try to have a smaller value, R. Let's go down and trying to help the other emitters. Okay, but it needs to be smaller, so let's try with 0.04, but we give more flow rate. So we have the beginning of the fluid simulation, then we have the new one that is helping to add fluid, but we have to make it down, and let's try to have more, 35, and again let's make a test. We have the initial fluid, and then we have the other one, and you see it's helping to rise the fluid in a faster way. Okay, Control S. Let's say that this one is as another comment, and this one is the internal emission support. So we know that this one is the secondary that is helping to have the fluid inside. Then now we can try to start playing with some force. So let's go to have this one here, and then we'll try to have a toroidal force. So we need to move it. I like to have it essentially near the middle of the bottle. So let's see what happens. Let's say that we have an higher speed. Okay, you see that it works perfectly. Okay, so let's reset. In this way it's twisting on the other side, but I like to make it twisting in the right way. Okay, and I like to have a fall off, so we'll have more twist in the middle and less twist. So let's say that we have a fall off that is linear, and the fall off is, oh yeah, this one is the toroidal. So let's try to use the line. Okay, so we are going to use this one and not the toroidal. Same way, you have to put it in the middle of the bottle. Okay, to see how it looks, let's say that it is 2, and then you see that it's twisting as the previous one. So let's say that the strength is 2, but then now we have the fall off that is based on this shape. So let's say that it's falling like this. So we should see the force just in the middle, as you see. Nice. Control S. And this one is the older, let's say, fluid twister. Okay, let's go to have a turbulence set to off this one and see what happens with the turbulence. You see that we have turbulence inside, and we can do the same. So we can use a mask. So let's say that we are going to use a cylinder, show force mask. And this one is here in the middle. Let's say that it's bigger and it's higher. So let's say maybe 50. It's really high. And let's say that the fall off is a little bit visible. So now we should have the turbulence just in the middle, but obviously the turbulence is touching also outside. Let's say that we have an higher octave, and about the scale maybe we go higher, and about the amplitude a little bit smaller, and we go higher with animation, let's say 25. So we have a lot of turbulence over the fluid. Okay, nice. Let's go here in the meshing and see what's going on over the fluid. If we double check with 0 ISO value, we see a precise visualization of the fluid. Let's go to F back. This one is wave turbulence, and this one is wave mask. Okay, Control S, R, and then we press, and you see that now we have together the trees, we have the waves, and we have also the other emission. So we are creating a lot of stuff together. Okay. Nice. If you like to be faster, obviously you can add an additional emitter, really big, that give you the possibility, we can make a test. Let's say that we have another emitter, and this one is set here. It is bigger, so let's say 1. Obviously it will stay in the wrong position, but it's good to to see what's going on if we have also this one. So you see that we have a lot of fluid coming inside. Yeah. By the way, we try to have it later because you see it's going to be too fast. And this one is the emitter number 2. Let's call it add, just to know which is. And we go to add here. Let's double check again. Just some small tweaks to the lighting. Just something more interesting. This one can be useful when we have the path tracer. So you see in this way it's really faster. So let's double check. It can, it can give us a really boost to the feeling of the water bottle inside, of the fluid, the liquid, whatever else. But we have to tweak the position and also the amount of fluid that is used to emit. So you see that this one is really, really big. Let's say 0.7. And then we can try again. Okay. We have to see together what's going on. You see now we should have the emission, and we have to decide if we like to have it here or we like to have it more deeply, but it is helping the fluid to go up. So in this way we can rise up in a faster way the fluid, and then we can decide when we like to stop the fluid simulation. Okay, stop, and let's say that this one, Control G, and we say fluid boost emission. So we know that this one is the boost of the emission. Okay, and Control S. So we have essentially the emission, so it's essentially just the beginning, obviously. Let's go to have a little bit more space here. If you go here to work over this one, obviously it works in a different way. For example, you have no emission. Then we can play with the transmission to find the best compromise between it, and we can have maybe just a little bit, and then you see that here we have the possibility to tweak, but the standard shader has not so much possibility, so it is just for the purpose to create something that is simple. So let's see in this way. I will try to have something that is something like that, maybe. If you go with the roughness, obviously you will have a roughness over the surface for the reflection. By the way, let's say that this one is enough for the purpose we have. So it's going to simulate in a fast way. We have not so huge problem simulating the stuff inside. And then if you go to have back the bubble, obviously it's not able to simulate together, but you have always the path tracer that can give you the possibility to see how it is looking, simulating everything together. Okay, so that's more precise, and you have the possibility to have a really nice preview. Obviously the material needs to be readjusted. So you have to go back here, decide which is the amount of absorption, and find a better setup, you know, because it works in a different way. So, by the way, that's not the important area, so you can just play with this one for tweaking the stuff. So let's go back here and say that this one is not visible. Okay. So the initial part is essentially having the bottle that it's filling. So to do something like that, we say to go to a simpler substance level, so it's faster, and we go to have a lower resolution. Sorry, this one is higher. Sorry. Apply. Okay, so in this way, you know, it's a really fast way. Obviously we have some problems, but don't worry about it. It's related to, obviously, to the substeps and the voxel side, so don't take care about it. But it's nice to know that around 1002 we should stop the emission. Okay, so let's say that if we go here, we can say that this one now is set to off, and the second one is set to off. Okay, but we have no animation here, so we have to say that this one is animated and this one is animated too. So here we say off, and here we say off. Then we go at the beginning and we say that this one is on and this one is on. So let's double check. We have the first one is working, then we have the other. We have the really fast emission. It's rising up. And then we should see a stop. And it should start stabilizing. Okay? We have a little bit of emission, but let's don't care about it. We have to make a test to be sure that it's working perfectly. So let's go to 2, and then we say to go to 0.08 and apply, Control S, and then we should simulate. To do something like that, we can say that we like to see also render, so we can see the preview together, you know. So let's say that the source is the viewport. Okay, it's rendered over an RGB frame. We go for a sequence, and let's go for a 7020p, and let's say for 1500 frames. Folder, we go over there, orange, preview, V001, that's the first version we are going to generate. Let's go, it's okay to use the project name, and then we go, it's really long, by the way, let's say that that's okay. Play blast, and then we say to use 4 digits, and that's the name. Okay, Control S, and then we can go to render. This way you see that it's simulating, but maybe we can see obviously from the camera what we see. So let's set to the right position so we see the entire bottle. Okay, Control S, and then export. Yeah, override. So rendering is done, and we see also that the maximum number of vertex was achieved. So we have to do something. We have to use an higher value, so it was not possible to render. So let's go here, and let's say that's, let's go to 25 millions. Okay, and just to be sure, we go for a little bit lower level for the voxel, because we have to be sure that it will be able to create everything. And about the boost, this one, maybe we say that this one is animated, but we say that it stopped to push water before. Okay, so let's try to export again the frames and override, and it will be really fast to simulate and render. You see something around 1 minute. Okay, we got no error from the render. Sorry, so we can simply the final result is going at 60 FPS using the same setup we have inside LiquiGen. So you see that for the moment everything is moving in the right way, it is boosting, and then it is going to stop in a few. Okay, obviously we are still the force that is moving, so we have to stop also the force. We have to play with the forces, and maybe we can have something about related to the camera animation. So we use the boost when the camera is rising up. So I think that's the perfect result for the stuff we are trying to achieve at the moment. So in the next lesson we are trying to cover the camera animation. We are going to tweak the fluid simulation and the force animation, and then we have to continue to add the other fluid sim and to finalize this setup. So guys, thanks for watching. We'll talk more about LiquiGen really soon.